Okay, balancing an oxidation reduction in base, you do it the exact same way as you do it in acid. There's just one extra step at the very end. So let's start with 31A. Got aluminum solid. Okay. So elements in their most common state have an oxidation of 0. Oxygen's got a -2, so that means this manganese must have a +3, -2, +4, and the oxygen's -2, the hydrogen's +1, and the aluminum is a +3 because it has to add up to that overall -1 charge up there in the corner. So that's why the aluminum is a +3. So we need an oxidation and a reduction. Okay. So what we have here is something that we don't run into often, and I was wondering that this is a peroxide. A peroxide is a -2, and each oxygen has a -1 charge on it. So in that case, my manganese is going to be actually a +2 oxidation, not a +4. So the reason why I knew that is because I know that I must have a reduction, and I didn't see a reduction. So the manganese, so this is a peroxide with each oxygen having a -1 charge on it. Okay? That's manganese peroxide. That's how I know it's manganese. That's how I know it's a peroxide. All right, so now we've got our reduction. My oxidation is the aluminum. So we balance the manganese with the manganese peroxide. Then we balance the oxygens with water. We balance the hydrogens. And now the charge. I've got a +3 on this side, so I'm going to add 3 more electrons to balance my charge. My aluminum is balanced with this goofy thing over here. And then balance the oxygens with water. I've got 8 hydrogens and 4 here, so I balance my hydrogens. And then to balance my charge, I'm going to need 3 electrons. Okay, so that's kind of, wait, did I balance that charge right? Yeah, I did. So that's kind of nice because my electrons for both the oxidation and reduction are 3, so they cancel. So I don't have to multiply by anything. So I have 4 waters here and 2 there. So that means I'm going to be left with 2 waters. I've got 4 there and 4 there. They cancel. 8 and 4. I just want to double check this real quickly that I balanced this right. Yeah, I balanced it, right? Okay, so then we have plus the aluminum. Okay, so this is balanced in base because this aluminum hydroxide would rather be this plus an OH group, and the OH group would be basic. So let's go on and do 31B. Okay, this is what it really means to do something in base 31B. You'll see the extra step. The extra step wasn't in this problem, okay? But 31B will have the extra step. So we've got chlorine gas becoming chloride plus OCl 1 minus. So ions have the same oxidation as their charge. Elements are that, 0. And I've got a chlorine here. Well, my oxygen's -2, so then this chlorine has to be a plus 1. So here I have a situation where my chlorine is acting as my oxidation and my reduction. So again, this is a good problem to see something like this. So my reduction is chlorine, and my oxidation is chlorine. All right, so when I do my reduction, I'm going to balance this chlorine with the chlorine that was reduced. Okay, I'm not going to use the OCl because that one is not being reduced, that one's being oxidized. So that's why with my oxidation I will balance it with that chlorine species as opposed to that one. I'm going to need a 2 there to balance that and a 2 there to balance that. There are no oxygens in the reduction, there are no hydrogens in the reduction, so that is balanced. Okay. My charge, I'm going to need 2 electrons here to balance out the charge because I got a -2 on that side, so I got to have a -2 on the reactant side. Okay. Here I've got 2 oxygens, so I'm going to need 2 waters. That gives me 4 hydrogens, so now I'm going to need 4 hydrogens. And then my charge, I'm going to need 2 electrons to balance out. I got 2 electrons for the reduction, I got 2 electrons for the oxidation, so they balance, so I don't have to multiply by anything. So what cancels? Just the electrons. So I'm going to end up with 2 waters plus 2 chlorines, giving me 2 chlorides plus 2 of these plus 4 H pluses. Okay, so there's an H plus here, so that's balancing in acid. But didn't the problem say we should balance in base? So to balance it in base, we just do one extra step, and 31A did not have this extra step. But to balance it in acid, you add hydroxide to the side with to both sides but you add it to the, you want to make sure it's got the same number of moles as the side with the H+. Okay, so if I've got 4 moles of H+, I want to make sure that I add 4 to each side. Okay, so what I'm going to do is I'm going to add 4 hydroxides to each side. I picked 4 because those guys will combine to form 4 waters. Okay? So now what you get is 4 waters on the right side, but you also got 2 waters over there. So these 2 waters will now cancel with 2 of those that you just formed, and then our overall reaction becomes this. 4OH plus Cl2 plus 2Cl minus plus 2OCl plus 2 waters. Okay? So it's still balanced. You can check it out. There's still the same number of oxygens on each side. There's still a number of chlorides. But now we have an OH, so that means it's balanced in base. Okay? Whereas before, when you see H+, it's balanced in acid.